Hello, welcome back to Teltech 360. I'm your host Mohammad Wahajuddin, and this is our second video in the Understanding 5G on Earth series. If you are excited to learn about 5G technology, you are in the right place. Today, we will explore more about the 5G era, the evolution of mobile generation, and the 3GPP standards that define modern wireless network. I'm a little fast because I think today video is gonna be a little longer. So I will move fast. 5G is not just about faster internet, it's the backbone of the fourth industrial revolution, unlocking the full potential of artificial intelligence, automation, and Internet of Things. This new generation of wireless technology is 100 times faster than 4G with near instant response times. That means zero buffering, zero lag, and a completely transformed digital experience. But speed is just the beginning. So, what really makes 5G revolutionary are its five core superpowers. First, super broadband. Forget slow downloads and buffering. We are talking about the real time streaming and instant cloud access. Second, ultra reliable low latency, which means that device communicate with almost no delay. That's what makes self driving cars possible, allowing them to react in milliseconds. Third, massive connectivity. Imagine billions of smart devices working together seamlessly from smart homes to entire smart cities. Fourth, high reliability. 5G networks will not just be a fast, they will be stable and always available, even in the most critical situations like emergency response. And finally, energy efficiency. Despite its power, 5G uses less energy per bit of data transmitted, making it more sustainable. Now, let's talk about how 5G is transforming industries. In manufacturing, we are seeing fully automated factories where machines and AI work together without human intervention. They self diagnose problems, fix themselves, and increase efficiency like never before. In transportation, 5G is making self driving vehicles a reality. Cars will no longer just drive, they will talk to each other. No traffic signals, even to pedestrians, smartphones, creating safe roads and reducing congestion. Healthcare is another game changer. Imagine a surgeon operating on a patient in another country through a robotic arm that responds instantly with zero lag. That's not sci fi. It's already happening with 5G powered telemedicine. Doctors can now diagnose, consult, and even perform procedures remotely, bringing high quality healthcare to places where it was never possible before. And then we have smart cities. 5G is powering AI driven traffic management, smart energy grids, and connected public services that make cities cleaner, safer, and more efficient. Even public safety will improve, and emergency response will get real time data from accident scenes, while artificial intelligence powered surveillance will enhance security. Beyond industries, 5G is also transforming entertainment and communication. Virtual reality and augmented reality will feel more lifelike than ever. Imagine gaming without lag, live streaming in 8K, or even attending virtual concert where it feels like you are right there in the crowd. Even phone calls will evolve. Soon we will have holographic calls where people appear right in front of you in real time. But what does all this mean for the economy? 5G is not just about the technology, it is also about money and jobs. It is not just big technology companies that will benefit. Industries like agriculture, retail, and even education will see massive improvements. Now, of course, with any new technology, challenge exists, and deploying 5G at a large scale requires massive investments in infrastructures, and government and businesses need to collaborate to roll out 5G networks efficiently to ensure that no one is left behind. But one thing is clear, 5G is not just an upgrade, it's a revolution that's shaping the future right now. So, what's next? Well, while 5G is just beginning to take over, scientists are already working on 6G, a future where artificial intelligence driven networks, satellite based internet, and quantum computing will take connectivity to unimaginable levels. The way we interact with technology is changing, and the possibilities are limitless. Now, have you ever wondered how we went from these old brick sized phones with terrible call quality to today's lightning 5G smartphones? The journey of mobile network is nothing short of incredible. In this video, I will take a quick trip through time and explore how mobile technology has evolved from 1G to 5G and what is coming next. So let's get back to where it all started, the first generation of mobile networks or 1G. Back in the 1980s, mobile phones were nothing like a sleek device we have today. 1G networks were analog, which meant calls were often low quality, had a lot of noise, and could easily drop. There was no texting, no internet, and no encryption, which means conversation could be interrupted or intercepted. But despite its flaws, 1G changed the world. For the first time, people could make calls while moving. Then came 2G, which was a game changer. 2G is the era of digital mobile communication, and in the 1990s, we saw the shift from analog to digital networks, and this is where things started getting interesting. 2G introduced text messaging, picture messaging, MMS, and encryption, making calls more secure. This was also the time when mobile phones became more accessible, leading to a global mobile revolution. But people wanted more than just calls and text. They wanted internet on their phones, and that is where 3G stepped in. 3G, the internet revolution of mobile, and in the early 2000s, 3G networks brought high-speed internet, allowing people to browse the web, send emails, and even stream videos. This was the first time when smartphones started becoming popular and social media apps began to take over. Video calling also became possible, and mobile networks became an essential part of daily life. However, as internet usage skyrocketed, 3G speeds were not enough. The people demanded faster connections, HD streaming, and real time gaming. 4G, the era of speed and streaming. With the launch of 4G in the 2010, we entered the era of ultra fast mobile internet. Suddenly, downloading application, streaming in HD, and playing online multiplayer games became smoother than ever. This was the backbone of service like Netflix, YouTube, and Uber, which require a fast and stable connection to function properly. 4G also introduced voice over LTE, which is called VoLTE, which improved call quality, making voice sound clear. But as the world became even more connected, 4G network started struggling with handling billions of devices, leading to the development of 5G. 5G, the future is now. So, we are in the era of 5G, and this is not just an upgrade, it's a revolution. 5G is 100 times faster than 4G, with the speeds reaching up to 10 Gbps, gigabit per second. But speed is not the only benefit. 5G brings ultra low latency, meaning devices can communicate in real time with almost no delay. This is what makes things like self driving cars, smart cities, remote surgeries, and virtual reality possible. With 5G, billions of devices from smartphone to industrial robots can connect and operate smoothly. Gaming, AI, and Internet of Things are all evolving and creating more connected world. So here's a question, what's next? 6G and beyond? Yes, even though 5G is still rolling out, scientists are already working on 6G, which is expected to arrive around 2030. 6G will be even faster, possibly 100 times quicker than 5G, and will integrate artificial intelligence, quantum computing, and space based internet. Imagine a world where holographic calls, brain computer interfaces, and AI powered assistants are part of daily life. That's the future we are heading towards. So, in just a few decades, we have gone from bulky analog phones with a poor quality to ultra fast AI driving 5G smartphones. Each generation of mobile network has transformed the way we communicate, work, and live, but the journey is not over. The future of connectivity is just beginning. So, now this is the last topic of chapter 1, 3GPP standards. 3GPP standards third generation partnership project is a global collaboration that develops technical specification for mobile communication standards, including 3G UMTS, 4G LTE, and 5G new radio. These standards define how mobile networks function, ensuring global interoperability between different telecom operators and equipment manufacturers. 3GPP release specification in phases. Release. which introduce new capabilities and improvements. Now we have 3GPP organizational structure. 3GPP consists of two types of members, organizational partners, SDOs, and market representative partners. In organizational partners, these are regional telecom standards bodies that oversee and contribute to 3GPP specification, in which you can see ARIB Japan, ATIS North America, TIA, TTC, CCSA, and in market representative partner MRPs. Organizations, basically these organizations represent industry interest and ensure that 3GPP standards align with the market needs. GSMA, 4G, America, COAI, India, GCF, these are basically partners, market partners. Now, 3GPP working process, Project Coordination Group, PCG. The Project Coordination Group is responsible for overall project management and coordination, assigning tasks to different technical specification group, approving new work items and releases, managing collaboration between organizational partners. The technical specification group further break down into working groups that focus on radio access, core networks, terminals, and system architecture. 3GPP has three main TSGs, technical specification groups, each focusing on a specific area of mobile communication. These TSGs create and maintain technical specifications which are later adopted as standards. So number one, TSG RAIN. RAIN basically radio access network, and it focuses on develops all radio related technologies including 5G new radio and LTE enhancement. And key working areas are RAIN 1, 2, 3, 4, 5. In RAIN 1, physical layers specification like modulation, MIMO, beamforming. We will cover it later. And in RAIN 2, it is working areas is radio interface protocols. RAIN 3, network interfaces and architecture. And in RAIN 4, it is basically radio frequency requirements and spectrum planning. And RAIN 5 area is covers testing and conformance for device. Examples of work are developing 5G NR waveform and massive MIMO. Also spectrum planning for millimeter wave and sub 6 gigahertz band, and also enhancing LTE and 5G coexistence. Number two, we have TSG CT. CT means core network and terminals, and it works on protocols and interfaces for connecting devices to mobile networks. And its key working areas are CT1, CT3, CT4, CT6. In CT1, protocols for voice and data sessions like SIP, VoLTE, VONR, voice over new radio, VONR, and VoLTE, voice over LTE. CT3, signaling and network interfaces, NGAPs, GTP, and diameter. CT4, core network internetworking, IMS, emergency call. CT6, SIM card and authentication standards, eSIM, USIM. And examples of work is developing VONR, voice over new radio for 5G, enhancing 5G device authentication and SIM technologies, also standardizing interoperability between LTE, 5G, and Wi-Fi. Third is TSG SA service and system aspects, and it focuses to define the core network architecture, security, and overall system design. And key working areas are SA1. SA1 defines service requirement for mobile networks. SA2 develops 5G core network architecture. SA3 security and privacy standard for mobile networks. SA4 multimedia technologies like video streaming, voice codecs, and Internet of Things. And SA5 network management, slicing, and orchestration. Examples of work: developing 5G standalone core architecture, implementing network slicing for industry specification use cases, and enhancing security in 5G authentication and encryption. So if I summarize these 2 or 3 slides in a simple words, is basically it ensures global compatibility. All mobile network follow common standards, and ensured drives innovation, enables new features like 5G NR, URLLC, ultra reliable low latency, and Internet of Things, and supports multi-vendor ecosystems, allows defense manufacturers to work together, and also enables evolution for future technologies like prepares the roadmap for 6G and beyond. So the 3GPP working process and TSGs play a critical role in shaping the future of mobile networks, making 5G and eventually 6G a reality. Now, 3GPP releases. 3GPP specifications are published as release, each adding enhancement to mobile networks. And release 15, the first 5G standards, was released in 2018, and it defines 5G new radio specification and introduced non-standalone NSA, which relies on 4G LTE for controls signaling, and also improved LTE with gigabit LTE speeds and massive MIMO. And release 16 is about 5G expansion and optimization, and it introduced standalone 5G, like it removes the dependency on LTE, and also improved ultra reliable low latency communication URLLC for mission critical applications, also enhanced vehicle to everything for autonomous driving, and also introduced 5G network slicing for industry specific services, and released 15 in 2022, evolution of new cases, evolution of new use cases, and it expanded 5G IoT Internet of Things to support low power devices and introduced 5G satellite communication for global coverage, also optimized extended reality for metaverse applications, and release 17 also improved private 5G networks for industries. And that brings us to the end of chapter 1. I hope you enjoyed this part, and in the next video, we will cover chapter 2, which is demands driving 5G evolution and essential drivers for 5G technology growth. So stay tuned and do not forget like, share, and subscribe so you do not miss what is coming next. See you in the next video. Bye bye.